Alright, we are going to try out some of these polynomial inequalities programs, and I'm going to try out this little screenwriting deal. Hopefully this isn't too miserable to read and write with, because it's a lot easier to record on my computer screen here. But we're going to look at problem number 5, a polynomial inequality, and then we're going to do a couple other examples as well. So the first thing you want to think about is just looking at this polynomial and making sure it's equal to 0. That's going to be the big deal. So this polynomial x squared plus 5x plus 4 is equal to 0, or less than or equal to whatever it may be. If you have something like this down here, problem number 8, you need to make that equal 0 before you actually start doing this problem. So once this is equal to 0, you're just going to factor this like you would any other problem. Now, since this has an a value of 1, just an x squared and not anything else, we're going to have two binomials that just start with x. And we have to figure out what goes with them, of course. Now, I trust you know how to do basic factoring, but if you do need any help with that, I'll send you some links to some other videos I've already made on factoring. So factors of 4 that add up to 5, well, that would be 4 and 1. So we're going to have x plus 4, and we're going to have x plus 1. Now here's the deal. We have to figure out, well, what does this mean in terms of being less than or equal to 0? You're going to take each of these independently and set it equal to 0. So you're going to write x plus 4 equals 0. And you're going to have x plus 1 being equal to 0 as well. And we'll deal with that inequality here in a minute. I just like to deal with equals because it's a little easier. If you solve each of these for x, you're going to find, of course, this one is x equals negative 4. And you're going to figure out this one is x equals negative 1. Now, what you want to do is if you are looking for interval notation, I like kind of writing this on a number line. It helps me think about it. You have this point at negative 4. And you're going to have this point at negative 1. Every time you have a polynomial inequality, what's going to happen is either they're going to be connected in the middle, it's going to be a line or an interval that will go in between these two, or you're going to have an interval that goes all the way up to negative 4 over in this area, and then skips to negative 1 and goes all the way up. That's the only options you're going to have with polynomial inequalities. So instead of trying to deal with this less than sign, because things get a little weird there, I'll be completely honest, I like to choose a number that is easy to solve this equation with. So like, I'm going to choose the number 0, right? 0's over here. If I plug 0 into this equation for x, if this equation proves true, then that means 0 is a number that is included in our interval. If it proves false, then 0 is not a number included in our interval. So what's going to happen is I will look at my original equation, x squared, well, if I made that 0, that's going to be 0. Plus 5x, again, if I made x, that's going to be 0 again. 0 plus 0, and then we just get 4. Is 4 less than or equal to 0? No, it's not. So that means 0 is not part of our notation, or our interval, my bad. So that means that is not a good value. In that same vein, if you tried a number on this side of things, it would not work for us. Like, if one of these sides doesn't work, neither side will. But just to go to show an example here, if I tried out negative 5 right here, negative 5 squared would be 25. 5 times negative 5 would be negative 25. 25 minus 25 is 0. Plus 4, well, that's 4. 4 is less than or equal to 0? Again, no, it's not. So that tells us negative 4, or negative 5, my bad, does not work. That goes to show that whatever word I'm trying to say here, inadvertently, this middle is going to work. I'm just going to, again, just for the sake of example, I'm going to try out negative 2, because negative 2 is a number that's in between those. So this should work because the stuff on the outside didn't. If I tried this here, negative 2 squared is 4. Let me try writing there. All right, there we go. Negative 2 squared is 4. Plus 5 times negative 2, that would be negative 10. So 4 minus 10 is negative 6. Negative 6 plus 4 makes negative 2. Negative 2 is less than or equal to 0. So this is a value that works for us. So everything in between here would be great, fantastic, awesome. Since this is or equal to, then it would mean these values work as well. The -4 and the -1 do in fact work. So we would write this as interval notation. As the lowest possible value this can be, since this is our only interval, the lowest possible value is -4. The highest possible value is -1. And since it is or equal to, and those values can be it, we're going to use brackets. So always remember that if one of these outside values doesn't work, if you try 0 or whatever number may be on the outside of your middle interval, if one of these outside ones doesn't work, the other one will not work either. And if one of the inside values work, let's say you just try the inside one first, if that inside value works, then the outside ones won't. Since this is a singular interval, we don't need a union involved here or anything like that. Let's do one other example of a problem like this. I am going to try out this problem 8. If you need help on problems like 9 here or something, let me know, like 9 or 10. I don't imagine you're going to be doing problems like that, because those are a little bit more advanced than, you know, college math classes tend to get to, or just written a little differently than those classes tend to get to. But if you do need help on those kind of problems, let me know. So like I said here, we want this to equal 0 to start things out. So we're going to subtract 6x, right? We're going to subtract that from here as well, which is going to make this written as x squared plus 10x plus 24. So x squared plus 10x plus 24, factors of 24 that add to 10, well, that seems like, what, 6 and 4, right? So we get x plus 6 and x plus 4 as our two binomials. And I guess it won't let me write off this page. Darn it. Let me try to clear this out a little bit and write smaller. Again, this is my first time using this screenwriting deal. So we get x plus 6, x plus 4. If we set each of those equal to 0, we realize that our kind of key numbers here are -6, and our other key number is -4. So on my number line, not a good arrow. My number line is going to have -6 on it, and my number line is going to have -4 on it. So what I want to do is I can choose any number that I just kind of like. It doesn't actually matter which one we do. We can do a 0 if we want to, you know, 0 is a good, easy number to use. Or we can choose a number in between here, whatever number you want it to be. I guess I should write greater than 0 here since we made that not 6x. So I like trying the number 0, quite honestly. It's just an easy number to use. So I'm just going to write a 0 there, and we're going to find out if 0 works on that side of the 4. So if I plug in 0 for these two, that's going to make them 0, right? 0 plus 0, and it's not going to change that 24. Now, is 24 greater than 0? Of course, it is. So that 0 does in fact work. That's good. So that means everything on this side of that -4 is going to work. Now, if everything on one side of this works, so will everything on the other side. So if I plugged in -7 or -10 or -1,000, whatever it may be, on this side of the -6, then it would work for the equation as well. Anything I plug in the middle here will not. Additionally, -4 and -6 will not work because this is not an or equals to sign. So that is not going to work themselves. So what we want to do is we want to write a interval notation for a problem like this. To do that, we want to go for our absolute lowest value, and if this is everything in this direction of -6, that's going to be negative infinity, right? And that's going to go all the way up to -6. Now, can you actually hit infinity? Can you be infinity? Not at all. So we have to have a parentheses there. Can the value be -6? No, because this is not an or equals to sign. So those are going to be two parentheses. Then since we have a second interval and we kind of have this break in the domain here, we're going to use our union symbol. We're going to open a new parentheses because it cannot actually be -4, and we'll write -4, and we're going to go to our highest possible value, and since it's everything above that, it's going to be positive infinity, and that may be one of the best infinity signs I've ever written, electronic or not. And of course it's infinity, so it cannot actually have a bracket there, it's going to be parentheses again. So kind of the big thing here on all these problems is just factor the equation, make sure it's equal to 0, factor the polynomial, and solve for what our roots are, if you're familiar with the terminology of roots, our values of x. Once you have those values of x, I like to plot them on a number line, and you can choose any number on that line. I always like to choose 0. And what you can figure out is if a number kind of on the outside here, quote unquote, like this 0 is in this case, works, then both of the quote unquote outside domains work. Both of those outside intervals will work. If a number in the middle works, then the ones on the outside will not. So those are our two different ways of doing, or the two different ways of polynomial inequalities of kind of functioning. If you need any other help with this, if you have any additional questions, if you have specific questions on an assignment that you need help with or you want to see done, then let me know and I will be more than happy to do those. I'm also going to film a video on rational inequalities here in just a moment, and I'll send that your way as well. Hope this helps.